Hello all. In this video we will look into object and its reference. So in this video we will create an first we will create a class, then we will create the instance, then we will study how object is created and memory is allocated, what is the role of reference and how it points to the created object. In Java world, creating an object is also known as instantiating the object. So to create the object, we should use the new keyword followed by the class name. So new, after that we will specify what type of object we are creating. That's why we specify the class name after the new keyword. So this will tell Java how what is the memory layout, how much space should be allocated in the memory layout. Those things will get resolved by the object type which we specify after the new keyword. So the new keyword not only allocates the memory, after allocating the memory it makes call to the constructor. So constructor is kind of a function, so it will invoke that function. So in this video we are not going to look into the constructor. We will study about constructor in some other video. So at the left side, what you are seeing is we are creating an instance. There are two parts. One is the part which is on the left hand side of the equal to, and another part is right side of the equal to operator. As already told, new object type. So what happens here is it allocates a memory for the object type, which is nothing but a class name which we will specify there. Usually it's a class name, but you can allocate array and other stuff also, but here in this video we will deal with a class. So and we will create a object out of that class. So here in our case in this video, this object type is actually a class template name. Once we know what is the class template name, the new keyword with the template name tells how much memory that needs to be allocated. Once memory is allocated, we need a variable to hold that memory. So here in the left hand side of the equal to operator, we once again specify object type and name. That name specifies the reference. Here we named it as a ref, but it can be any name. So this name will reach you to the object, which is the memory is allocated for the object, and the reference will point to that allocated memory. Alright, we will see more about this when we proceed with this video. So when we create an object, it will get created in heap. So there are two types of data types available in Java. One is primitive types and another one is instance type. Example for primitive types are standard data types like integer, float, double. So most of the language supports these kind of standard data types, and these types are usually created on the fly and it will go to the stack frame. But object which we create using the new keyword will never go to stack frame. The memory will get allocated in the heap. So this restriction is there in Java. I won't say it's a restriction, but that's how the Java handles it. In C++, it can be in stack or it can be in heap. So the developer decides that, but in Java, whenever an object is created using the new keyword, it goes to heap. say some examples. So for example, a class person, class product, and if you create an instance of it using the new keyword, then the object is actually created in the heap. That means memory is allocated in the heap, and the location of that heap address is stored in the reference. So we are talking about two memory segmentation. One is a stack and another one is a heap. Also, now we know that standard data types get created in a stack, and object types or instance types that will get created in the heap. So the stack frames live when you enter inside a function. Say for example, public static void main, that's the entry point for your Java program, and once you enter inside that function, a stack frame for void main get created, and that stack frame get destroyed once you quit the main function. That means this stack frame lives till the program ends, because that's the entry point, and when you exit, that means you are quitting the application. But let's say inside the program lifetime there will be multiple function calls. In the static void main, let us say we're calling some utility function in the string array, a string or math utility class, whatever it is. So once you make a function call, you will be entering inside the function, and inside the function, if you declare two data type, say an integer x and float y, then these two variable gets created in a stack frame. But this time this stack frame is different. Why? Because from public static void main, you are making a call to a utility class function. So this is a second function. Say for example, let us say it as a static void main calls function a. So once you are inside function a, you will be ended up with two stack frame. One is for static void main and another one is for function a. So since we told we are creating two variables, one is int and another one is float inside the function a, these two variables get allocated in the stack, and these two variables lives till the end of the function. So that means once the function call returns, or the method call for a returns, the stack frame for the method a get deleted. The frame get released. That means the memory slots are free, and it can be allocated for other stacks. Yeah. So that's about the stack frame. When we talk about heap, once a memory is allocated on heap, this memory lives beyond the function call. That means like stack frame, the memory in heap will not get deleted at the end of the function. So the heap memory will get deleted when there is no reference to it, and the deletion is taken care by a separate Java program called garbage collector. So the JVM maintains that. We will not dig into that much, but all you have to know is memory allocated in stack get released once the function ends, but whatever you allocate in heap lives even after the function call. Alright, so this is how it will be useful when you hold the reference and you transfer the reference between one reference to another reference. So even after the function call, you can still access the heap location and read or write data into it. So it's yeah, so at this stage this is enough to know. We will move on to the next one. Okay, in the left hand side you are seeing a template called person. So this is the class definition. The class name is person. That means we are defining a template here. So there are two parts here. One is the data members, another one is function members. The data members defines the state, and function member defines We have three data members here. One is age, which is a integer type, and another two are string type. By looking at this member itself, we can say int is a primitive type, that means a standard data type. So age is standard data type, fname and last name are object type, that is it's a string. Then we have a two member function. One is a set data, which will receive the input from the caller, and then it sets the internal members, fname, lname, age, those. Then print data will print the information in the class and the console output. That means it prints the person's name, then in the next line it prints the age. So that's on this class. Now we will look into the memory layout of this one. Let's say we are creating the instance of the person class. So as I already told, the left hand side of the equal to, we have person, so that is the class type. So let me go to the previous slide. If you see the class template name is person, so that's why we are placing here person, then the person, which is what called a name given to the reference. Person is the type, class type, the person is the reference. Then in the right hand side of the equal to, we are actually creating the object. So let us forget about the left hand side, we will concentrate on the right hand side. New person, that means we are allocating memory for the person class. So we know that the person class has three data members. So in the heap, Java will allocate memory to hold those three data members. So one slot is for string, another slot is for one more string, and third slot is for integer. Since integer is a primitive type, it will get stored in the slot here in the heap itself. Since a string is not a primitive type, it will get allocated in a different place, and that address gets stored in the next two slot. So we will see more about that in the next video. But here for now, you can remember that the memory for person is allocated in the heap. In the picture here, the red box shows the heap location. Java has plenty of heap location. I mean, plenty of space available on the heap. People also call that as a free store. That means you can allocate a number of memory there, and the Java garbage collection will do a neat job of always keeping this memory free when wherever the memory is not used by the application. So the top slot here, the red box shows the heap store, and the bottom blue box shows the stack frame. So there are two different segmentation. So in the picture you are seeing a memory with three slot to hold the three data members, and location we are assuming it as ABC. Right, so the new person will do this. It allocates memory in the heap. So that's what you are seeing. Alright, now we have a memory in the heap, and let's assume that the location is ABC. But how do we reach that memory? We know that the space is allocated and there is a three slot to hold the data members, and how will we reach that? So that's how the reference comes into picture. Now we will go to the left hand side of the equal to operator. So here we are saying the person is the reference that will hold the reference. But at the same time, since we reach into the memory, If we only have the person, then the application knows that it is some memory location where I can reach. But to bypass that memory location and read or write data into that memory location, we need the type. So that's why we specify here the person is the reference of type person. That means what it points to is a memory location, and that memory location is slatted out to keep the layout of a person. So this will help us to read or write the memory slots. So that means you can read age, or you can read the string or those stuff, or you can even access the member functions or methods. Right here, if you see, the heap will allocate memory for data members only. That means the 3 variables. What about the code? The behavior is actually function call, right? So that will be stored in a different memory segmentation that is not shown here. We call that as a code segment. There usually the translated code. Here in this case it is a byte code that goes and sits there. So even if you create a number of such instance, all shares the same byte code loaded into the code segmentation. But if you create n number, there will be n slots here in the heap. So each location is different, and the data it may contain also vary, but translated code is same. So that's why the same code segmentation memory is shared by say for example, if we create 3 objects, all 3 objects share the same code segmentation memory to execute the translated byte code of the behavior. But data members, it needs 3 different segments, and those get allocated in the free store here in the red box. Alright, now let's go to the stack frame, which is in the bottom. And if you see in the stack frame, let's say we are creating the object in the static void main. I mean the statement person, the person equal to new person, semicolon. This is in public static void main. That means the stack frame in the bottom is for the static void main. So if it is created in a function called a, and if a is called from static void main, then the stack frame is for the function called a. Alright, so the person occupies the space in stack frame. The actual object is in heap. So the location of the heap is assumed as ABC. That ABC gets stored here in the stack frame. Of course, to store that memory location, we again need a location identifier in the stack. So we can assume that as element. So the whole statement person, the person equal to new person, stands this. Object is created on the heap at location ABC, and that location ABC is stored in the stack frame, and that stack frame is identified, I mean the location in the stack frame is identified by the name called the person, and that is in the location element. So that's why we call the person as a reference here. So once you have the reference, you will know the location is ABC. The ABC is stored in element. The location is ABC. That means to reach the object, I have to read the heap location ABC. So once I reach there, then I have 3 compartment. From there I can read or write data, or I have associated function call which is in the code segment. That means there are some other memory slot here which is not shown here. There will be location offset here that will store the memory location of code segment to that means the function start. We can say there are 2 behavior. That means that 2 location is stored here in the LOC, which is not shown in the picture. For now, if you understand, the data members are allocated here. That is yeah. Here in the static void main, if we see, we have two example snippet. In the first snippet, we are creating standard data types. So in the first part, we create three variables. One is x, another one is y. Then there is one more variable called z. It holds the multiplication of x and y. So there are three variables. These variables are called standard data types. So where the memory for this will get allocated? This will get allocated in the stack frame. Stack frame of what? A stack frame of static void main. Suppose if there is a function call inside the static void main, say let's say we are making a call to a utility function multiply numbers. So that's the function name, and we pass these two variables to the multiply function. So once you enter inside the multiply function, there will be two stack frame. One is for the public static void main and another one is for the multiply function. Then the memory for the passed in variables get allocated inside the stack frame, which is dedicated for multiply. Once you come out of the multiply, those stack frames get released. That means whatever you pass it in inside the function, those get released. Alright, here in this case, the public static void main ends after making a call to print data. After that, the stack frame for main get removed. But here in this case, that is absolutely the program exit. Yeah. Okay. So the example code snippet 1 tells creating the memory for a stack frame. Now we are coming to the snippet 2. So in snippet 2, new person that will allocate memory on the heap. If you remember in the previous slide, the new person will allocate the memory on the heap. So there is a memory is available, and that memory can be reachable through person. So the person actually stores the memory location of the heap, and that heap will have the allocated object. Alright, so after that, what we are seeing, since we have the person is in stack, and we use the dot operator to access or to reach the memory location of heap and do read or write operation. Here the set data will perform the write operation. So the person dot set data, which will make a call to the method of person object. So we are passing all three data, that means the first name, last name, as well as the age, and it will set the internal data members. So that means through the person reference, which is in the stack, we are reaching out the actual object in the heap. Then we are making call to its method, and that method will perform the write operation on the three slats, and it stores these whatever we are passing here. After that, we are making one more function called the person dot print data. This will actually read the location which we already returned. So it reads those memory slats, and then it prints the data in the console output window. Alright, now let us create these two classes in the Eclipse and see how it works. So whatever you saw in the slide is available as code here in the notepad. So we need two Java file. One is a person.java, which defines the class template for person. Then in the object ref demo.java, we actually provide a program entry point for our Java program. Then we will create the instance of this person class. Okay, first we will create this person class in Eclipse. Eclipse is already opened here. First we need a project. We will create a project. File, new Java project. So just provided a project name, so we are using the default location. We'll accept all the default and we'll click on next. Here also we can accept all the default and click the finish button. So the project is ready. So now we need to add two classes. So I just right click it here, then click new, click on the class. So package, we can leave it as empty. We will read more about package in some other video. Here we have to give name for our class. So we'll copy this and give it as a name here, person. So here this in the default package is discouraged. You can leave that warning for now. Once we read more about package, we will dig into it. For now, since it is just a demo purpose, we can leave the package. So accept all the default. Here we doesn't need anything. I'll just click finish. If you see under default package, there is a file called person.java. Here you are seeing classes are created. Now we will copy the code from here and place it there. So instead of typing it, I just copy pasted. That's all. We have 3 members and 2 behaviors. After that, we need to create one more class called object demo. So this is the program entry point for us. Package, we will leave it as default. That means which will go here and create a file, and both class belongs to the default package, which means here in the object demo I can access the person class without importing any package. And since it is a program entry point, I'm placing a check mark here. I'm asking I need a public static void main. The public static void main acts as a program entry point for the Java project. So it's done here. Let's remove this. Okay, we will place this code from here. So now both classes are ready, and if you see, once you make a call to set data, that means the person object is created here inside the program entry point void main, and the reference is here the person, and this will allocate memory for the actual person. So it will allocate memory for these 3, then it will have memory slot to reach out to these 2 functions. So when we talk about memory, we can always think about the data members. These are all internals, we don't need to worry much about it. And when we call set data, we are making call to this public member set data, and if you see, there are 3 incoming parameters, and we use those parameters to set the internal members: first name, last name, age. So after the call set data, the memory slots are filled. So if you remember the slide, The new person will allocate a memory on the heap. There will be 3 slots, and in each slot we are filling the value which is passed as a parameter here. John, David, 52, all will get received here. Then we are pushing to it to the internal members. After this, we are making call to print data. Here this is actually a write operation. Here is the member, and for example, first is coming as an incoming parameter. First is John. John will come here, then John will get assigned to F name. So F name is actually a member. That means one slot get filled with the data John. The same goes for the other 2 parameters. So this is actually a write operation. Here below you are seeing a read operation. That means we are reading the data. Here we are asking the L name. That means it will read the internal member and appends that to this string. Alright, to execute this, what we need is we need to create a configuration. We'll go to run configuration. Before that, if you see, there are 2 classes. One is person and another one is object ref demo. But object ref demo has the program entry point. The signature here, public static void main, is the program entry point. And if I go for run configuration, okay, here in since this is a Java application, double click here. If you see here, there is only one project, so it doesn't give any trouble. Java basic demo, it get automatically filled here. This tab here, main, which says as part of this run configuration, it want to know where the main function exists. This is the main function, public static void main. That's why this tab is called main. So it is available in the project called Java basic demo. Then the project has 2 classes. One is object ref demo and another one is person. Person doesn't have any main function, but object ref demo has main function. So the Eclipse automatically searches those 2 classes. Since it knows that there is a program entry point in the object ref demo, it get automatically populated. So in some cases, you may be having a test program which may have multiple entry point. So in that time you have to go for search and automatically select the one. So, and you can name that run configuration as you can provide a meaningful name. So at a given time you can pick any run configuration and run that specific test suite. Alright. For now you don't need to get confused. Here we have 2 classes. One is Java basic demo, another one is object ref demo and person. Since object ref demo has the static void main, you have to make sure main class is inside this object, so it is correctly populated. So once that is done, click on the run button. So it will run and display the output. If you see here, person name is printed, last name, which is David, this is coming from here, one blank space, and then first name is John, it's printed. Since it's a print line, we are the next call will get printed in the next line. So after that we are printing the H. Alright, here our ultimate purpose is how do we create a object of class, and we can after that how we can start using it. In this demo we saw how an object is created. So this is the critical point here. The object is created like this. After creating the object, you can access its internal member through dot notation. Remember, when you are accessing it, you can access the public outside the class. So these are all private. You cannot directly access these members. If it is a public, you can access it. We will read more about this in a different video under a topic called access specifiers. So that's all in this video. Thanks for watching. We will see you in the next video. If you like this video, click the subscribe button and get the update whenever a new video get posted here. Thank you again. Bye.